the second video of this question because I was about to overrun my 15-minute time limit per video, so we're going to finish it up right here. To summarize what we had done so far, we set the two displacements of the bikers to be equal to each other because they are, and then we could find individual equations for the time of each bicyclist and express the times of each bicyclist with respect to each other, and we wound up with what looks like is going to look like a quadratic equation right here. So to make this look more quadratic, let's start by rearranging it. So first of all, the entire equation is set equal to 0, and we'll start with our ax squared plus bx plus c, that format, and then we'll go about solving it a little bit later. So let's make this whole thing equal to 0 on this side right there, which means on the right hand side, let's start with the t squared section. So we've got 1/2 times a, acceleration of the biker, times time of the biker squared, plus initial velocity of the biker times the time of the biker. So to get the rest of this over to the right side of the equation, we would have to subtract this whole left-hand side and put it on the right-hand side. So minus 1/2 times the initial velocity of the friend plus final velocity. Oops, so what did I do there? Oh, that's supposed to be an F. Final velocity of the friend. Okay. Times the time of the biker plus 2 seconds, or plus 2. And the reason we put the time of the biker here was because we substituted the time of the friend as the time of the biker. This is right here because we're solving for the time of the first bicyclist. So that's why it's plus 2 seconds. Okay, well, can we simplify this even further? Yes, we can. And one thing we can do now to simplify it is actually start putting in some values, because we're going to find that there's going to be some zeros in there. The zeros will make some of these things go away. So we have 1/2. Oh, this is all equal to 0. 1/2 times what? Well, the acceleration of the biker is 2.4 meters per second squared. Times, what's the time of the biker? Well, we don't know that yet. Time of the biker squared. So that's going to be kind of our x value, like ax squared plus bx plus c equals 0. That's our standard quadratic format. So this is going to stand in for where x would stand in. So that's our tb squared, which we don't know, plus our initial velocity of the biker. Well, that's handy because that's 0 meters per second times the time of the biker, which ultimately will go away. Okay, minus 1/2 times initial velocity of the friend is 3.5 meters per second. Oops. Plus the final velocity of the friend, which is 3.5 meters per second, times the time of the biker plus 2 seconds. Sorry, I had to squeeze that in there. All right. So this simplifies. Let's simplify this even further. We have a half out in front of this 2.4. So, in fact, I'm going to shift this over a little bit. On half of 2.4 is 1.2 times time of our biker squared. This whole middle part went away. Minus, well, we have a half in front of here, and we have a 3.5 plus 3.5, so they basically negate each other. If we want to write it out, it would look like 1/2 times 7 times TB plus 2 seconds equals 0. And of course, like I said, 1/2 of 7 is 3.5, but I'll write it out again. 1.2 times time the biker squared minus, this would be 3.5 times the time of the biker plus 2 equals 0. And what we can do now is we can distribute this 3.5 to the TB, to the time of the biker, and to the 2. So it will be 1.2 times the time of the biker squared minus 3.5 times the time of the biker. And since there's a minus out front, we are subtracting everything that will become of us distributing this 3.5. So really, it's going to be minus 3.5 equals 0. So this all simplified down to 1/2 times time of the biker squared minus 3.5 times time of the biker minus 7 equals 0. This is your standard quadratic format, and we can very easily punch in our 1.2 as, that's our ax squared right there. That's going to be our bx. That's going to be our c equals 0. So put in 1.2 for a, negative 3.5 for b, and negative 7 for c. And that's going to give us two answers. The more reasonable answer is the positive one, because you can't have negative time. So the time of the biker is equal to 4.3 seconds. Now that's time of the biker riding. Okay, that's the amount of time spent by the biker riding his bike to catch up with his friend. The question asks, how much time does it take until he catches his friend? Well, it could be interpreted two different ways. Either way would be acceptable to me. Riding, it would take 4.3 seconds, but since he delays 2 seconds before getting on his bike, it could also say that the time of the biker, TB total, is at 4.3 plus 2, so that's 6.3 seconds. So 6.3 seconds total after his friend passes him, or it could be written 4.3 seconds if you're merely considering the amount of time riding by the biker. Like I said, either would be acceptable. The question is not even specific enough to ask which time. The answer does indicate that 6.3 is the correct time, so it would be assumed that this would be what the question is asking for, the total time of the biker. But either way, it's a small calculation in between, and the two times otherwise are similar. So that is homework 2.57a. And now that we've gotten through all that, I think you'll find that B and C are going to be much simpler, but we'll save that for another video yet. See you then.